So thinking about how we represent these integers, right, with children or when children are beginning to learn these ideas, we start to look at something called a set model, and we use counters, or we call them two-color chips, to represent positive and negative. And there's websites and stuff like this one here. Let's see. On our course, I have the two-color integer tile link that you could play with, that I'll at least show you so that we get an idea of what we're talking about here. And so again, as we're thinking about this, we have colors. One color represents a positive and one represents a negative, right, as you look at those there. And so we use those to kind of represent a situation. So looking at this situation here, one positive, one negative represents zero, the idea that they cancel out with each other. So if you put a positive, let's go red is negative, yellow is positive, that this is zero, they cancel out. So no matter how many I have out there, this is still zero. That's what we would have, right? This to me is like you have -3 and then +3, and if you put those together, if you group them together, you get 0, and that's what we're looking at there, okay, in terms of that. But we have these tiles that represent that. So what number would I have now, right? You have a -1, let's get that out there, -1, this is a +2, and if you put those together, this and this would cancel out, right? They would cancel out, and so you would be left with a +1, right, if these are negative there. So looking at that, that's one way that we look at that as a set model, okay? And so you definitely want to read up on that and look at that, because we're going to use this idea of these chips to kind of help us think through the values of these positive and negative numbers. And so another way we look at it too, and again, I leave this text here so you can read it, okay? Another way to think about this is through what we call the measurement model, which is a number line, right? We measure things out. How far from 0 are you? And so in the set model here, -4 and +4 here, you can see the sets, each set. So when we combine them, that would be 0 here. Another important idea that I've highlighted here is the opposite, right? When you think about +4 and -4, here's +4, -4, right? Really, you can think about is the opposite of the integer. So they're both 4 from 0, but it's the opposite direction, right? 2 and -2 are opposites of each other. And so the negative means opposite. So many times, for example, if I say, if I do a problem like this here, many students get confused, like a negative times a negative. Well, really what you're doing is the opposite of -5. The opposite of -5 is +5. So something to think about, I want you to be aware of these models that we have here. Opposite, right? Think about that as the opposite of -5 is 5. So that negative really is making it the opposite of what value that number is. And so a way to see that again is on the measurement model. That's the way to look at that. We're going to talk about addition and subtraction next. And of course, before we do that, we need to look at properties, right? Again, integers are a set of numbers, and we've got all these properties that are involved with other types of numbers that we've talked about before. And here are some properties that go along with integers, some rules, right? Anything +0 is itself. Adding 2 positives, right? They are added as like whole numbers. Adding 2 negatives, right? Take a look at what you do here. Look at a formal way we do it, right? They're both negative. What you can do is you add the positive values of them, and then it's the opposite of that. And then we'll learn again some of our rules of when it's positive and negative, when one's bigger than the other. We'll talk about those properties, but it's definitely worth looking at the rules that emerge when we do that.